everybody. Hope all of you are doing well. Already we have seen costing area for this AW examination. Okay. So now we are going to see the area of surveying and let us see how the questions came and how actually we are going to kind of questions. Okay. Let us see the very first question. A surveyor measured the distance between on a plan drawn to a scale of 1 centimeter. It was 33 meters. Later, however, he discovered that he used a scale of 1 centimeter, 25 meters to find the true uh, scale distance between the points. Okay. So the question is very clear here. The surveyor measured the distance between 2 points on a plan drawn to a scale of 1 centimeter. Okay. And the result was 333 meters. The result was 333 meters. Later, however, he discovered that he used a scale of 1 centimeter. Actually, he was supposed to use this. Actually, he was supposed to use the scale, but accidentally the scale of 1 centimeter. Now, by using the scale of 1 centimeter, 5 meters, he got a distance of 33. Fine. Now the question is find the true scale distance between the points. Okay. Now the surveyor, what he have done, he have measured the distance in between 2 points by a scale like 1 centimeter is equals to 25 meters. But he was supposed to use a scale of 1 centimeter is equals to 100 meters. Okay. So the question is very simple here. No need to take any formula kind of thing like to find out the correct scale or to find out the correct distance. Okay. By using the simple mathematics, we will be able to solve such a kind of questions. Now see here, this is the correct scale that he was supposed to take. The correct scale he was supposed to take, but he took a wrong value of 1 centimeter is equal to 25 meters, which was 4 times lesser than the actual scale. Okay? Which was 4 times lesser. You can see here 25, that this is 100, this is 25. Okay? So he is taking 4 times lesser value for his scale. Okay, and he found out the value to be 333 meters. He got a distance as 333 meters. Now what is it we are supposed to find out here? Find the true scale distance between the points. Scale distance. Okay, now this is a true scale, right? The true scale he was supposed to take with this scale. Okay, now he is asking the distance that we have take, that means the distance that we are going to get when we using a true scale. Okay, so now this is the distance that he was supposed to find out. Fine. So now true scale is the 4 times than the scale that is taken, than the wrong scale, Okay. If we just multiply that 333 with 4 times, then we will be obviously get an answer. Okay, because you can see clearly here, this 1 centimeter is equal to 25 meters is the wrong scale that I have taken. I was supposed to take a scale of 1 centimeter is equal to 100 meters. It was 4 times than that of this scale. Now, obviously, the answer would be 333 times of 4 because he himself took the scale as a wrong scale. 4 times less than the scale he has taken, that he have to take. Okay. So now, when 1 centimeter is equals to 100 meters, this is the true scale. Is a true scale. Okay. But he took a scale of 1 centimeter is equals to 25 meters, which was the wrong scale. Now, when he used this wrong scale, he got a value of 333 meters. Okay, he got a value of 333 meters. Okay, which was 4 times lesser than this. Okay, which was 4 times lesser than this. If I simply multiply this with 4, I will be easily able to get the correct answer. Okay, now simply what you are going to do here, multiply the 333 meters by 4 so that you will be able to get the correct answer. 4 is 12, 13, 4 is 12, 13, 13, 32 will be the answer. So this is a simple, clear answer that we will be able to find out by using the simple mathematics. So no need to go for any kind of formula like true distance and the true distances from the scales. No need to go for such a kind of formulas here. Simply just follow the logic, then we will be easily able to answer such a kind of question. Here, to be more clear here, he is not specifying more on the subject here. He is specifying more upon the mathematics point. Okay? Very easily, we can easily answer such a kind of question called. The answer for this question will be 1332 meters. 1332 meters. Okay. Now this is the first question. Now the second question. Calculate the area in the square meters enclosed between the survey line, the irregular boundary, and the first and the last offsets by Simpson's rule. Fine. The perpendicular offsets were taken at 20 meters interval from the survey line to an irregular boundary line, and he gave the ordinates here. Okay. Now he is asking us to find out the simple question here. Calculate the area by using Simpson's rule. So he is asking us to find out, calculate the area by using, okay, not a trapezoidal rule, Simpson's rule. Okay, Simpson's rule, which we do call it as prismoidal rule. Okay, so by using the Simpson's rule, we are supposed to find out the area, and we do the formula of the Simpson's rule, the Simpson's 1/3 rule, which we do call it as d by 3 into first ordinate plus last ordinate, first ordinate plus last ordinate, plus 4 into sum of even ordinates, plus into sum of odd ordinates. Okay, by using this formula, we will be able to find out the correct area by using these ordinates. And remember here, for applying the Simpson's rule, we are having a condition. For applying the Simpson's rule, we are having a condition here. The number of ordinates should be odd. Odd ordinates have to be there. Finding by you for using this formula. Okay. So if you find out here, this is 1, this is 3, 5, 6, 7, 8, 9. Here, so we have seen that 9 number of ordinates are there, which are the odd ordinates. So we will be easily able to apply such a kind of formula for this kind of ordinates. Okay. So simply apply that Simpson's rule. So D is nothing but the interval that is that was taken here. So you can see here D is 20 meters. Clearly you can see D is 20 meters. 20 meters interval has been taken. Okay. We are supposed to place 20 here in the place of D. 20 upon 3, 1/3 rule. First ordinate 5 plus last ordinate 5.6. So here the ordinates once used should not be used once again in this formula. Okay, plus 4 into sum of odd ordinates. Now search for the odd ordinates. 5.40 into sum of even ordinates. Sorry, 4 into sum of even ordinates. So the even ordinate is 6.50 plus the next even ordinate 6.65 plus the next even ordinate 6.2 plus the next even ordinate 6.5. Okay, and now into odd ordinates. So the odd ordinates were here 5.40 plus 7.85 plus 2.35. That's it. They're not supposed to take any value that already we have taken. Okay. So once we have used these ordinates and we are not supposed to use these ordinates once again this formula. Now do that simple mathematics so that we will find out the answer. Here the answer comes around here. I think it's 950. The answer comes out to be here 950. The answer comes out to be 950 here after doing that simple mathematics. Okay. 950. The meter square will be the answer because here we are supposed to find out area, right? Calculate the area. It will be in terms of meter square. Of course, he nowhere mentioned the meter squares. Okay, so all the values will be in terms of meter square. So here we will be able to get an answer of 950.02 or 950.2 something like that. It will be coming, and the nearest value for that answer will be 950 meters. The correct answer. Okay. Now let us see the next question. The survey carried out to delineate the natural features such as hills, rivers, forests, and man-made features such as towns, villages, and buildings, roads, transmission lines, and the canals is classified as. Whatever the survey that we are carrying out, delineate the natural, call it as a topographical survey. Remember this here. Whatever the survey that we are carrying out for delineating the or physical or the physical feature of the Earth's surface, physical feature of the Earth's surface, we do consider it as topographical survey. Called as a topographical. Okay. Now let us see the other options also. What are the other options dealing with? Okay. So we do know that topographical survey is the correct answer. Now what does a geological survey deals with? Geological survey deals with strata of the Earth's surface. Strata of the. What does it mean here? The formation of rocks, types of the soils, etc. The rock formation, soils, studies. Okay. So this kind of strata of the Earth's surface will be dealt in an area called as geological survey. That's engineering geology. Okay. Land survey deals with all the measurements, and both land survey and engineering survey deals They will be dealing with. Okay. The natural features such as hills, rivers, forests, and man-made features such as towns, villages, buildings, roads, transmission lines, etc. And canals are classified as. Remember, the answer for this question will be of topographical survey because topographical survey deals with the physical features. Okay. So if the options were given like cadastral and so on, the cadastral survey deals with the boundaries. Cadastral survey deals with the boundaries. Why? Because we also have to know the other things or other types of the surveys. Deals with the boundaries. Okay. Hydrological survey deals with the water bodies. Hydrological survey deals with the water bodies like the catchment areas or the discharges or runoff water bodies. Likewise, the archaeological survey that deals with the archaeological things like the old things. Okay. Likewise, we are having other different types of surveys are also like geographical survey is also there. We can also take this geographical survey that deals with the atmospheric conditions. Geographical survey that deals with the conditions. Okay. And also we are having mine survey that deals with the minerals. We are also having military survey that deals with the strategical important place. Okay, so we have to know all of the types of surveys so that we will be easily able to answer this kind of question. Now let us see the next question here. Consider the following statements. Okay, a few statements were given here, and we are supposed to find out the correct statements. Yeah, we are correct. We are supposed to find out the statements that are correct. Okay, the question is cumulative errors are more important than compensating errors. All cumulative errors are equally important. The more times a line is measured, the more likely the accidental errors to disappear from the mean. And the variation in temperature results in the compensating error. Okay, if you see these options, all the options sounds to be similar, and it's very difficult to find out the correct statements here. Okay, but easily we will be able to identify the incorrect statements from the kinds of four options that were given. Now, cumulative errors are more important than compensating errors. Yes, obviously, cumulative errors are more important. Why we have to consider this important here? Because they will be moving on either in terms of positive or negative values. Okay, that means the summation will be going on increasing because we do cumulative error is nothing but in the summation of the errors. Okay, cumulative sum, which we do call it as. Okay, here the value will be going on increasing while we are carrying out the survey. Okay, cumulative sum will be going on increasing either in terms of positive or either in terms of negative, but the value of error will be getting increasing. Okay, the value of error will be getting on increasing. Okay. That's why this cumulative error is obviously more important than the compensating error because we do know compensating errors are not that it won't have that impact. Okay, that doesn't mean that they are not there errors. Compensating errors are also there, but then they can be compensated. They can be compensated. Okay, but these cumulative errors they can't be compensated, right? So obviously cumulative errors are more important than the compensating errors. Yes, that is correct. Okay, so all cumulative errors are equally important. Yes, all cumulative errors are equally important. Yeah, fine. All cumulative errors are equally important. Yes, all the cumulative errors are equally important. Okay. So because the cumulative sum will be going on increasing, the cumulative sum will be going on increasing when we are going in the forward direction. That means either in terms of the positive or in terms of the negative. Okay. So we can easily state that all cumulative errors are equally important. Okay. Now let us go for the third statement. The more times a line is measured, the more likely the accident error to disappear from the mean. See here, the more times a line is measured, that means if you are measuring a line for the multiple times, okay, the more likely the accidental error is to disappear from the mean. Yes, if you are measuring the same line or if you are measuring with the accidental errors when you are measuring a particular distance, okay, if you are dealing with more number of times, that means if you are counting out with more number of times, then there will be a probability to reduce that error. Okay, because every time we won't do this accidental error. Okay, and we do have to understand like this accidental errors will be positive as well as negative. Okay, so when this positive is continuing, then the next reading might be a negative reading. Okay, like here if you try to understand more times, that means sometimes it might be positive and sometimes it might be negative, because accidental errors occurs in both the directions of positive and negative. That means in both the ways of positive and negative. Okay, so the more times a line is measured, the more likely the accidental errors will be disappear from the mean. Yes, it obviously will disappear from the mean. That means at some point it will be disappearing from the mean. Okay, now the variation in the temperature results in the compensating error. Temperature variation in the temperature, it's not actually compensating, it's a cumulative error. Variation in temperature is a cumulative error, it's not a compensating, a cumulative error. Okay, so please remember variation in temperature, it's not a compensating error, it's a cumulative error. But if you try to understand this question, all the three options were correct. A, B, C, and three options were correct. Okay, so but here in this options A and C were there, A and C, which is also the correct thing. and A and B, this might also be correct thing. So here there might be a question that will be arising in between which option will be the correct answer. If you observe this thing more clearly, all cumulative errors are equally important might be the not justified statement, because he mentioned the cumulative errors, because he haven't mentioned like what kind of cumulative error is coming into the picture. Like the cumulative error might be due to the fault in that system, or the cumulative error might be due to the any other reasons like bad ranging. Okay, so see, he is not more specific here. If you try to understand, he is not more specific here. He have included all the kinds of cumulative errors. Okay. Here, if you try to be more clear with this statement, I will be writing the statement like all cumulative errors are important. All cumulative errors are important. I will be making statement like all cumulative errors are important. But I can't say like they are equally important. I can't say that they are equally important, because there might be different types of systematic errors, different types of cumulative errors. Okay, so different types of cumulative errors yield to the different results. Okay, so that might be a question here. That means the option might be in between 1 and 3. We have to discuss it more in detail. Okay, so up to the question strategy, the answer might be in between. The answer might be only one, that is A and C, because he clearly mentioned like all cumulative errors are equally important. Okay, but if you justify that statement more clearly, cumulative errors are important. That is clear. But all cumulative errors, like different kinds of cumulative errors, will be coming into picture, and justifying in that way, like all the cumulative errors are equally important, might not be the suitable option. Okay, so more preferably, we going with this A and C. We have to see that statement is also correct, but to be more imprecise. Okay, to be more imprecise, we can't go with this option. Okay, but let us see how the key will be given. Okay, let us see the next question here. The length of a line measured with a 20 meter chain was found to be 300 meters. Calculate the true length of the line if the chain was 15 centimeters too long. Now we have to check. The length of the correct line, that is the true length of the line. Okay, so we can use a simple strategy here, that is true into true is equals to false into false. A general simple strategy that we will be following while dealing with such a kind of questions in chain surveying, errors in the chain surveying. Now the length of the line is measured with a 25 meters chain. The length of a line is measured with a 20 meters chain. I haven't observed anywhere this 25 meters chain, but he has given this 25 meters chain. Nowhere, whatever the different types of chains we are taking, like metric chain or revenue chain or surveyor's chain or engineer's chain, nowhere I haven't seen this 25 meters kind of chain. Okay, well, let it be the thing that was given, we have to accept that. So the length of the line measured with the 25 meters chain was found to 300 meters. Fine. Okay, calculate the true length of the line if the chain was 15 centimeters too long. Now the point is the chain that you have used, that means the standard length of the chain, that is the true length of the chain. Standard length of the chain. The standard length of the chain has given 25 meters. Fine, 25 meters length was given. So this one true is for the chain, one true is for the distance that they have measured. Okay, one false for the chain, one false for the distance that they have measured. We can use a simple relation to find out the any unknown value regarding this chain surveying, any unknown value from this errors of the chain surveying. Okay, or else we can go with that general textbook formula like L dash upon D dash into D. Like we can go with the textbook formula also, but we will be for us to deal with such a kind of relation, that is true into true is false into false. Now one true chain length, that is a true chain length was here 25 meters. The true distance, we don't know the true distance, because 300 meters is not the true distance, because clearly he mentioned like the chain was 15 centimeters too long. That means there is an error in the chain, and because of that error, whatever the distance that he has measured also will be wrong. Okay, so obviously on the true distance, we are supposed to find out this true equals to false length of the chain. The chain was 15 centimeters too long. Okay, 25 meters, which is the given chain length, plus 15 centimeters. Nothing but I'm applying the correction here for the chain. Just I'm applying correction here for the chain. Okay, because when the chain is too long, the correction is positive and error is negative. Okay, into the false distance of the chain, the false distance that I have measured is 300. Okay, now from here we will be able to find out the true by simply making it as a subject 25.15 centimeters. That's why just if you convert it in terms of meters, it comes out to be like 25.15 meters into 300. Okay, upon this 25 12 300. If you simply multiply that, you will be able to get that answer clearly. That more clearly, the question number 40. The answer comes out to be like 301.8. The answer easily comes out to be like 301.8. You can use a simple calculation. No need, no requirement of any calci also here. That means no calculator is required. This is a small calculation. Okay, so this is how this question will be getting solved. Okay, now let us see the next question here. The type of the surveying in which the curvature of the earth is considered. Very basic, general, simple question. Okay, the type of the surveying in which the curvature of the earth is considered is called. We do know when we are considering the curvature of the earth, because the earth is having a curved shape throughout it. Okay, so whenever we are considering this curvature of the earth, then obviously it will be coming under geodetic surveying, because based upon the accuracy, we will be having only two types of surveyings. They are geodetic and plane surveying. Based upon the accuracy of the surveying, generally we do take two types. They are geodetic and plane surveying. Where in geodetic, the earth's curvature have to be considered, and in plane surveying, the earth's surface is considered to be plane surface or a horizontal surface. Okay, so clearly we can easily give the statement called geodetic surveying. In plane surveying, here the curvature is not considered. Here this is considered to be a plane surface. The earth's surface is considered to be plane surface. Okay, and now preliminary surveying. This is a type of surveying that deals with the engineering surveys of the alignment. So this is the first. This is not a suitable option for this kind of question. Topographical survey that deals with all the physical features of the earth and surface. We do call it as a topographical survey. Okay, this is how we will be easily able to solve this question. Question number 52. Match the following errors in the training. Okay, so here a few questions, a few statements were given for which we have to select the correct option. Errors in the reading. Error in reading the tape. Fine. Error due to temperature. Error incorrect counting of the tape lengths. Bad ranging. Variation in the pull. Okay. So see clearly here, beta. Error in reading the tape. Observe the options here. Cumulative in terms of positive and negative. Cumulative positive. Miss. Compensating in terms of positive and negative, and blunder mistake. Okay. You can clearly mention like the error in reading of the tape will be coming under a mistake. Okay, because that's a personal error. Okay. So, and that can be compensating also. Okay. Now, error due to temperature. Error due to temperature, it can be positive or it can be negative. Or see, error due to temperature. Error temperature can be positive or negative. Temperature can be positive or negative. This can be positive or negative. Okay, like when the temperature is too high, when the temperature is too high, the mild steel might get expanded and that lead to that the negative error. Okay, and when the temperature is too cold, that might be getting shrink and the value will be getting lesser, leading to the positive error. Okay, so this will be cumulative in terms of positive or negative. That will be dependent upon the time, like whether it's a hot temperature or cold temperature. Okay, so this statement, that is error due to temperature, can be cumulative with positive or negative. So I'll be going B with negative or negative. Okay, the third thing, incorrect counting of the tape lengths. See here, he directly mentioned like incorrect counting of the tape length. He is not mentioning like incorrect reading of the tape lengths. Incorrect counting, that will obviously lead to a blunder mistake. That will be obviously lead to a blunder mistake. Okay. So now variation in the pull. Variation in the pull. Now you can see here. Sorry, bad ranging. Bad ranging will be always cumulative and it will be positive. Bad ranging will be positive in terms of cumulative. Why, sir? Why we are considering this bad ranging as the cumulative error? In a sense, this can also be considered as the personal error. And but here, what is ranging here? Ranging is a process of establishing or drawing a straight line by using these ranging rods. Okay, so by a ranging principle, that means by ranging method, we are going to draw a straight line by establishing multiple ranging stations or these staff stations or the ranging rods. Okay, now what is the point here? If we make a single error while taking this first reading, or at least here, okay, now because of the error, there might be change in direction of the movement that this ranging process is getting continued. Now, if you see that the error is going on increase, we are moving in the forward direction. Okay, now we do know that ranging, in the ranging process, we are going to establish the third station, okay, in the line of two stations. Okay, now if I place a third station with a little bit error, and now that have to be continued, because ranging is a continuous process where we are going to establish, or where we are going to draw a straight line, okay, which is beyond the limit of this chain, right? So now in this ranging process, we have to draw a longer line than the length of this metric chain or whatever the chain that we are taking here. But when in the process of drawing this longer line, by using the process of ranging, there might be an error. That means with the very first reading getting with the error, that error will be getting prolongated. That means getting increased forward direction. Okay, it won't get decreased. It's going on increasing forward direction. So obviously this error, that is the bad ranging, will be a cumulative positive error, because the error will be going on increasing one direction. Okay. Now the variation in the pull can be compensating, because we do know that variation in the pull, it is compensating. Okay, and also we can consider this variation in the pull as an personal error that can be compensated. Okay, and this can be positive and negative. So find the E option will be 5. So if you see these relations, A for A it is for A it is 3, for B for A it is 3, for B it is for B have taken it as 1, for C it is taken as 5, for D bad ranging we are taking it as a 2, and for E we are taking it as 4. Okay, check these options 3, 1, B1, 5, D4. So obviously option 1 will be the correct answer. Okay, now this is how we will be easily able to justify all these statements. Okay, so if you take the next question here, match the following. So tachymetry, contouring, leveling, theodolite, compass, different instruments were given here. That is compass and leveling is a method, contouring is a method, tachymetry it's also a method. Okay, if you try to understand this question here, multiple streams were covered in a single question here. Okay, now let us see what is it we are going to, how we are going to match these options for that given questions. Okay, so compass surveying, obviously, whatever the angles that we are taking from this compass, we do call it as bearing. Bearing is an angle taken with respect to the meridian. Okay, and that will happen only in this case of a compass. Okay, now theodolite, tachymetry, contouring. Contouring means that will be an equal elevations. Okay, that will be an equal elevation. Remember, contour line is a line drawn by joining all the equal points. What is a contour line? What is a contour line? Contour line is nothing but a line formed by joining all the equal elevated points, formed by joining all the equally elevated points, all the equally elevated points. This process of obtaining all the contour lines by closing within the map or of the map, we will be calling that procedure called contouring. Contouring is nothing but an equal elevation. Okay, leveling deals with elevations. Leveling deals with elevations because we do know compass surveying is an angular instrument. But here the more suitable option will be bearing. Okay, now the option remains here will be in between tachymetry and theodolite. Okay, so here if you consider the options, the remaining options, angular surveying is there, horizontal and vertical angles are there. Okay, more precise here, theodolite is for measuring the horizontal and vertical angles. And tachymetry is a method where we are going to measure the angular surveying. Okay, you can take, that means to be more precise here, of course, we do have the theodolite can also used for an angular measuring or angular surveying. Okay. But tachymetry, it is a method, it's not an instrument. Okay, so in this method, we will be able to find out this angular surveying. Theodolite is an instrument, be able to find out angles. Okay, so clearly justify the things in between the method as well as the instrument. So by theodolite, it is an instrument, angles, tachymetry procedure. Okay, where we are going to use an instrument called tachymeter here, finding out the angles. Okay. By using this procedure of tachymetry, we will be able to find out these angles here. Okay, so tachymetry is more related to angular surveying. So very simple, right? Take this A, that is a tachymetry, that is angular surveying. Now B, contouring, that deals with elevations. Leveling deals with elevations. D, theodolite, horizontal and vertical angles. And E, compass surveying, that deals with bearings. Check the answer. It was there A1, B4, C5, D. Obviously, option 3 will be the correct answer for this question. Okay, let us move further. Convert the circle bearing of 211 degrees 54 minutes to a quadrantal bearing. Very simple question, just a conversion is asked to convert the whole circle bearing towards a reduced bearing system. Okay, so take down the figure, represent the given bearing in the quadrantal system. Okay, so this is a whole circle bearing, and we know that whole circle bearing have to be taken to the north, and it have to be taken only in the clockwise direction. Okay, and we do know this 7 degrees 54 minutes comes in the third quadrant. Here this is the third quadrant, so I have taken the line. It is bearing that was given was 11 degrees 54 minutes. So this is the whole circle bearing. Now we are supposed to find out the reduced bearing, and we do know that the reduced bearing will be taken either with the north or south as the reference line. And we have to we can move in clockwise or anti-clockwise direction as well. Okay. Now we are supposed to find out the bearing of this line in terms of reduced bearing. So we can clearly state that this line is nearer to south, and we are supposed to find out this angle. Okay. So simply from that 211 degrees 54 minutes, if you subtract 180 degrees, you will be easily getting the answer because you just need to move this value, right? Okay, so just remove 180 degrees so that you will be able to get the required value. Okay, This is 54 minutes, so it comes out to be 54 minutes. This is 1 degrees, 18, 19, 20, 21, 31 degrees, 54 minutes, and it is lying in between south and west. This line is lying in between south and west, so the option will be south 31 degrees, 54 minutes west. South 31 degrees, 54 minutes west. This is the correct answer. Okay, so easily we will be able to convert the conversions. Okay, let us see the next question. If the formation level of the highway has a uniform gradient for a particular length and the ground is also having a longitudinal slope, the earthwork cannot be calculated by. See here, it is not can be calculated by, it is cannot. Cannot. Okay, so already we do know in the area of in this concepts of areas and volumes, we have used different methods to find out these areas and volumes. Okay, where we are going to use Simpson's rule, which we can also call it as Prismoidal rule or Prismoidal formula. Okay, at the same time, trapezoidal rule, we have used trapezoidal rule also for finding out the areas and volumes. Likewise, we have used mid-section formula, nothing but mid-ordinate or mid-section formula. So all these formulas, they were used for finding out the areas and volumes. Okay, but only the formula that is given here differently is center line method. Center line method. Actually, the center line method is a method that is comes under the estimation and costing, where we are going to find out the volume of a structure or the area of a structure by using the center lines. And also we will be able to observe one more method there in the estimation costing, like long wall, short wall method. Okay, so this center line method, by using the center line method, it is we are not going to, or we are not supposed to find out the slopes. But here in this question, you can see there is a longitudinal slope, and we are supposed to find out the area of that longitudinal slope, which is not possible, or we won't do by using this center line method. So this is not the correct way, okay, to find out the slope. So cannot by, that means cannot be calculated by center line method. Okay, because in center line method we will be only able to calculate the areas of, not the sloped areas. Okay, and we are going to calculate only the regular areas, not the sloped areas. Okay? The correct option for this kind of question is center line method is a correct answer. Because you can see here, it is cannot be. Okay, it's not can be, it's cannot be. So all these types of rules we have used in the calculation of areas and volumes area, right? Now see the next question here. The diurnal variation is more at magnetic poles and less at equator. Does not change from year to year. More in winter and less in summer. More in daytime and less in night time. The question is regarding the diurnal variation. We do know when we are dealing with the magnetic declinations, we do observe a topic, or like in declination, we do observe something called as variation. And this variation can be diurnal, can be seasonal, or it can be like we do have different types of secular variation. Okay, like we are having different types of variations. Now he is asking about the diurnal variation. Okay, so in a sense per day. Okay, so it is obviously more in a day and less in the night time. Yes, the diurnal variation will be more in the daytime and less in the night time. Okay, it is more at magnetic poles and less at equator. Yes, it is more in magnetic poles and less at equator. Okay, it is not more in winter, because at winter or the lesser temperatures won't impact the declination angle. Remember. Okay, so in winter we won't have much temperature, so it won't affect this variation. Okay, so it is less in summer. No, this is not the correct statement. That's a suitable statement. Okay, and it diurnal variation does not change from year to year, because duration variation we do take it for the days. Okay, so obviously it does not change from year to year. So the clear answer in between for this A, so for this one third, not third question, will be A and D. So you can go directly with A and D. Now, if you observe this question, a theodolite is placed at P and a 5 meters long vertical staff is held at Q. The depression angle made at the reading 3.5 meters marking on the staff is 7 degrees 15 minutes. The horizontal distance in P and 2500 meters. The height of the 1.5 meters and the level of point 980.50. Curvature correction, diffraction correction, determine the RL of point. Actually, this is also a kind of previous gate question. Okay, the thing is here, why I have here the most important thing is solving such a kind of question without using any calculator. It's a little bit difficult task here, because we also need to find out this curvature correction as well as the diffraction correction. That's why here the calculator is more useful for solving such a kind of question. Okay, now if you see in a diagrammatical point of view how the question will be, is Okay, so now just let us dump all the data that is given in terms of a diagram. A theodolite is placed at P. Okay, the theodolite is placed at P. The 5 meters long staff is held at Q. Okay, a 5 meters long staff is held at Q. Fine. The 5 meters vertical staff. Okay, this is held at Q. Fine. Now the depression angle made at 3.5 meters marking. So this is the line of collimation. Theodolite. So after this instrument, after the telescope being truly horizontal, whatever the line that is passing through the optical center of the instrument as well as the cross section of a diaphragm, we do call it as the line of collimation. The line of collimation. With respect to this line of collimation, you will be able to find out the line of elevations and line of depressions. But here the given thing is the depression angle. Okay, so obviously the angle that we will be taking here will be a depression angle. Fine. Depression angle was given on a staff is 7 degrees 15 minutes, and this depression angle is now 7 degrees 15 minutes. Fine, 7 degrees and 15 minutes. The horizontal angle, the horizontal distance between P and Q is 2500. Fine. So the horizontal distance here in between P and Q is 2500 meters, which is nothing but 2.5 kilometers. Okay, 2500 meters. Fine. The height of the instrument at P, the height of the instrument at P, fine. The height of the instrument at P is P. The height of the instrument at P is 1.5 meters. So this is 1.5 meters of reading. Fine. And the RL of the point P is 980.450. So this is a 98.450 meters. Fine. Using curvature correction and refraction correction, determine the RL of point Q. Using curvature correction and refraction correction, we have to determine the RL of point Q. Okay. So very easy. Now we are supposed to find out the RL of Q. We are supposed to find out the RL of Q. Okay. So we are having only this height, that is the line of collimation height was given. The line of height of the line of that is line of collimation height was given as 1.5. So 980 plus 1.5, 980.450 plus 1.5 will give us this line of collimation site, and we need to just subtract this value x, and already this value is given 3.5 meters. Already this value is given as 3.5 meters. You can see 3.5 meters on the marking. Marking on the staff was given as 7 degrees and 15 minutes. This is how the figure seems to be. Now I was supposed to find out, or I am supposed to find out the RL of Q, where I will be starting from RL of P. Let's backside reading. Okay, the RL of this point. Let's backside reading. Okay, minus x minus 3.5 minus combined correction, because combined correction will be always negative. We do nothing. Now we have to we are supposed to find out these two values, so that we will be able to substitute all those values here, and we will be able to find it out. RL of P already given 98.450. This backside reading comes out to be 5. Now I am supposed to find out the value of x. That x will be found out from this trigonometrical function. Okay. Now this is the triangle. I am taking it out here. 7 degrees 15 minutes, and this distance is 500. Okay. Now we will be able to apply tan 7 degrees 15 minutes is equals to opposite x upon adjacent, that is 2500. From here we will be able to find out the value of x. X is equals to 500 times tan 2500 or 25,000. 2500, yeah, 2500. Fine. So tan 7 degrees 15 minutes. Okay. So you need to have a calculator here to solve such a kind of thing. So if you solve this 2500 times and 7 degrees 15 minutes, the value comes out to be 7 degrees 15 minutes. The value comes out to be 318.040. Value comes into with 18.04017. Okay, 387 meters. Okay, because I have taken this as in terms of meters, so I will be getting result in meters only. Okay, this value x comes out to be 0.40. So I have to subtract this 18 minus 0.5 minus, I have to see for that combined correction also. So now combined correction formula 0.073 d square, and this will also be negative, minus 0.0673. This is C combined. For refraction 0.112 d square, and we do combined so this for curvature of the earth combined, for curvature of the earth this comes out to be 785 d square. Okay, so finally we are supposed to use only this one, that is 0.06673, and curvature correction is also negative. Okay, combined correction is nothing but combination of these two both. Okay, so if we take this combined correction, that is here I'll be that combined correction combined is 0.0735, that is nothing but 2500, will be taken in terms of kilometers here. because D have to be in kilometers here. D have to be in kilometers, but the result will be in terms of meters. Okay, so 2.5 square. This value comes out to be 0.0673. 2.5 square. The value comes out to be 0.420, which is negative. Okay, so I have to take it as a negative 0.420. Solve this equation so that you will be able to get the answer correctly. So this comes out to be 980.450, 1.5 minus, that means as I am getting down here, I need to subtract, minus 318.040, 318.040, and also minus 3.5, 660.41, 60.410, there will be 3.41, okay, 410 will be the correct answer. Now for solving such a kind of question, it is a little bit difficult without using any calci here, because here the point is that's not that easy to find out the value of tan 7 degrees 15 minutes without using any calculator, but there is no other option because we are not supposed to use calculus in this exam for AEE. Okay, so to find out the exact answer of 7 degrees 15 minutes, again we have to go for the linear interpolations and all that kind of stuff. Okay, take much time. So this is a kind of time consuming problem. At the same time, it's very difficult to solve this kind of calculations. So little bit time taking, time consuming. Actually, this is also a kind of previous gate. Okay, also kind of previous gate question. Okay, the values might be have changed, but the same pattern of question was there, which we have to use curvature correction and the refraction correction to determine the RL of some other point. Okay, so in this manner we have to solve this kind of question, but of course we do know this is a little bit difficult in terms of solvation, but the method is easy, but it is very easy when we are allowed with the calculator. Okay, but here no calci was allowed, so we have to deal with the calculations. No other option was left. So other calculations, getting an answer of 660.410. 0.410 will be the correct answer for this. Okay. A surveyor was reading a level staff as 4.935 meters. Later he found that the staff was 20 centimeters off the vertical through the bottom. Find the error of the reading. Okay, a surveyor was reading a level staff. Okay, so a level staff was there, fine. And what is the point that is for level staff as 4.935 meters. Later he found that the staff was 20 centimeters off the vertical. Okay, fine. So later he found that it is 20 centimeters off the vertical. So this is the vertical line, right? The vertical line, right? So now of this vertical, it is 20 centimeters off. 20 centimeters off of the vertical through the bottom. Find the error of the reading. So now if you see here, for example, I am taking the reading from here. So actually I was supposed to take upon this. Actually, I was supposed to take upon this, but I accidentally took this. It's an accidental thing, which was mentioned here. Later he found that the staff was 20 centimeters off the vertical. So 20 centimeters off. So here I have got a reading for this one. I have got a reading of 4.93. Here I have got a reading of 4.93. Okay. Now what is the point? This is 4.95 meters and this is meters. Now the question is find the error of the reading. Find the error of the reading. Error this much. Okay, let us see. Now how we have to get that error of the reading here? This reading, that means the exact reading when whatever he was supposed to take when the staff is vertical minus whatever the reading that he is taking from this direction. Okay, will be the error of the reading. So now we have to consider this as the side. Okay, this is, we do know hypotenuse. Okay, so both the sides were given. This is 935 meters and this is meters. We do know, we are able to find out this hypotenuse, the side length by taking this formula 4.95 square. 4.95 square plus minus 0.9 minus, because hypotenuse square is equal to side square plus side square. Right? I have to subtract this side. So 0. Square. Okay, so we will be able to get under root. Okay, so that is what the vertical height comes out to be. And if you try to measure this, actually here I am using calci, but we are not supposed to use it. Okay, so 4.935 square minus 0.02 0.20 square, The value comes out to be 4.930. Value comes out to 0.9 4.930. Okay, but not that is not the actual thing. 4.9309. But he is not asking this value. He is asking us to find out the error of the reading. So he is asking us to find out the error. In a sense, that will be 4.935 minus 4.930 something here like this. So if you take this 4.935 minus answer, the value comes out to be 0.004. 0045. So this will be the answer actually. That should be the answer actually. But he is asking actually that this is error. This is not these are not the errors. Okay. To find the error of the reading, so in his way, the nearest option might be 4.931, but this is actually objectionable options were given here. Okay, but the nearest answer 4.931 meters, right? Question. If you see the next question here. The observed bearings of the traverse were given here. So the observed bearings were given, fine. So PQ, okay, bearing was given, QR bearing was given, RQ bearing was given, RS bearings were given, SR bearing was given, and TS. We do know that the forebearing and back bearing difference of a particular line will be equals to plus or minus degrees. Okay, so when the value is lesser than 180, we have to add 180 to that bearing. Okay, now just we be able to check the difference here so that we will be able to justify whether the difference here is getting 180 or not. Okay, so here this is 180 because 225 minus 45 is obviously 180. Fine, equals to 180. Now if you find this out, 107 degrees 15 minutes minus 286 degrees 15 minutes. So it is not 180. It comes out to be like 286 minus 107. That comes out to 179 or 179 like that. It will be coming into picture. Not equals to 180. Fine. This is not equal to 180 degrees. Okay. So now see here. Now whatever the bearing we are taking from the Q will be correct. From the P will be correct, and whatever the bearing that we are taking from the Q will be correct, because for this line PQ or QP, the difference coming here will be equals to 180. Okay. That means whatever the bearings that we are taking from these two stations will be correct, right? So here we can see this is, so obviously the readings that we are taking from Q will also be correct, right? So now there might be a question like, sir, the difference is not coming 180, then how come that Q will be correct? See here beta, in the very first station PQ, okay, the very first bearing, the 4 bearing from P was taken, and here for the station QP, for the line QP, here the 4 bearing was taken. The difference is coming here as 180 degrees. The difference is coming here for lines as 180 degrees. So obviously whatever the bearings that we are taking from P station and Q stations will be obviously correct. Okay. So here we can see the Q station, whatever the reading that we are taking from Q station will also be correct. But as the difference is not coming 180 here, obviously whatever the reading that we are taking from R station will be wrong. This reading correct reading. Likewise, here we are having R, so obviously the readings that we are taking from R will. Okay, so it's clear. Now, the difference in between 202 degrees 30 minutes and 21 degrees 30 minutes, this is also not equals to 180, also not equals to. Okay, and we can see that the station S is also involved here. That the station reading that we are taking from S is also wrong. Okay, so R is wrong, S is wrong. Okay, and also whatever the readings that we are taking from this S also will be wrong. Okay, now TS, but we don't know. That means we have to rectify this. We can't justify this T whether it's correct or not. Okay, so 141 degrees TS RST. The traverse is not getting close. However, the options are in between and RS only. That means QRS only. So obviously R and S is the answer. R and S will be the answer because Q is not the correct one, because we do have justified that Q is the correct option. That means the readings that we are taking from Q are correct, not only S. Okay, only R. No, it's not only R. R and S. We can easily justify this statement, right? Isoconic lines, a line of, you know, in declination we have seen isogonic lines, agonic lines. Also, we have also seen isoclinic lines, aclinic lines, and all this kind of stuff. There might be a little bit confusion here in between these, but if you know the subject well, we will be easily able to answer this kind of question. Isogonic means the declination angles having same declination, or simply I'll be writing like same declination points. Line formed by joining. So isogonic lines are nothing but line formed by joining equally equal declination other than 0 other than 0 degrees, we as isogonic lines. Isogonic lines means the same. That means the line that is formed joining all the 0 declination points, we do as agonic line. But here he haven't asked for agonic, he put isogonic. Negative declination, constant declination, positive declination, no. Is actually the negative declination, positive declinations comes towards when the declination is towards east, it will be positive. Towards west, it will be negative. Answers: 0 declination, agonic line. Okay, there is 0. And what are these and aclinic lines? These are not declinations. They are regarding the dip angles. So dip and the equal dip angles. Okay, but the question is not regarding this dip angles. That is regarding the declination. So same declination, agonic line will be the correct answer. Okay. And one more question here that have to be noted. Okay, which is not. I'll be writing that question. Okay, so the question here. Give me a minute. A level instrument is at a height of 1.350. A level in at an height of 1.350 meters has been placed at a station having a reduced level. The station having reduced level of 102.35 of 102.5 meters. Fine. The instrument reads minus 3735 meters on the leveling staff held at the bottom of deck. The RL of bottom of deck is dash. RL of bottom of bridge deck dash. Actually, this is a previous gate question. That was exactly pasted here for this AW level. Okay, the question is very simple. A level instrument is at a height of 1.350 meters. Level instrument which is at a height of 1.350 meters. This is 1.350 meters. Okay, so this is the backside reading that I am taking here. I think the height of the instrument, because he only said that the level instrument is at a height of the 1.350, but height of the instrument, which we take it from the line of collimation. Okay, so has been placed at a station having an RL of 102.365. So it was placed at a station. So here this is a station. Then RL was given as 102.365. The instrument reads minus 3.735 on the leveling staff held at the bottom of bridge deck. So we do know this is a deck of a bridge, deck slab of a bridge. Okay, and a leveling staff was placed here, which is inverted. Leveling staff is inverted. Why we are supposed to take an inverted staff reading here? Because clearly mentioned that the reading is negative. Reading negative clearly says that the reading, that means the reading that we are taking upon the staff is an inverted staff. Okay, so here the reading that he found out from this inverted staff is 0.735 meters. Okay. You are not supposed to subtract it beta. That simply says like the reading that we are taking is an inverted staff reading. So that's what the negative value remains there on the leveling staff held at the bottom of a bridge deck. Okay, so this is a bridge deck. a bridge deck. Okay, I haven't written the options, right? So let me write the options also. 99.98, 107.45, 116.72, 104.75. Okay, so these are the options that are given here. Okay, now just we are supposed to find out the RL of bottom. So this is the bottom of a bridge deck. Then nothing but this deck slab. Nothing but a deck slab of a bridge. Now I am supposed to find out the RL of bottom of this bridge. Okay, which is very easy and which is very clear. RL of bottom of bridge deck is equals to RL of the benchmark, which comes out to be like 102.365 plus 1.350. So I have reached up to here plus 0.735 will be the answer. Okay, so 1005 6. The answer comes out to be 107.45. 107.106 and all these together 3. So easily 107.45. Okay, so no any nearest option. So we will be able to go with this answer 107. Okay, so this is how this is all the questions that we got in the area of AW for this area of surveying. Okay, so you can see clearly the only point that we have to remember here while dealing with such a kind of exam is if you observe this exam here, little bit lengthier questions are there. Questions are easy, there's no doubt about it. But the point is here, without using calc, it takes a little bit time to solve. Not a little bit time, to be more precise, it will take more time only. But the only thing that we have to take care of here is regarding the calculation area. So we are not having any permission to take the calci along with this to solve such a kind of questions, but we are not having no other option other than calculating with more preciseness. Because if you observe the options are nearer to each other. So that was a very kind of thing that we have to take care of. So all the options are nearer to each other. So that's why we have to take more. We have to be more precise while dealing with the answers. Okay. So these are all the questions that we got in the area of surveying. So these are all the different questions that we got in the area of surveying. So here you can see all the different questions. Okay. So all the surveying questions were solved here. All the surveying questions were solved. Little bit confusion with this point here. We don't know how this key will be given by that subject expert, but the more precise option that we will be choosing here will be A and C. That doesn't mean A and B is wrong. It is also correct, but here there is a that needs to be a justified answer. But I don't know how that subject expert will be giving this answer. The length of the chain. So we have done this clearly by using this small technical, small kind of relation between the taken values. Okay, so you can see here we have easily able to answer. We easily able to answer this. Easily able to answer this question, and this is also very easy. Okay, so it's also very easy. So here also we do require some calc kind of thing to find out these answers. Okay, this is easy. Without using any calc, we will be able to solve this. And the theory question here also not calc is not required. So here you can see three questions were there, like where we need to apply the calc or we need to have a calculator kind of thing. Have a more fast and precise answer. Okay, so this is all about the area of surveying. Thank you.